Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. So you can recall actually that in the last lecture we had initiated a discussion that how to conduct simple calculation in the R software, and we had basically considered the operation where both the numbers are say simple number, they are not in the form of data vectors, but in R many calculations are done with the data vectors, and the combinations can be when you are trying to work with one scalar, one data vector, or both of them are data vectors, and then the data vectors, they are of the same size or different sizes. So different types of combinations are there in which the mathematical operations are being done. So in this lecture I want to give you some basic fundamental that how R works when we are trying to work with scalar and data vector, and whatever I am going to explain you, that can be extended to any number of or any combination of say more than one scalar and more than one data vectors. So let us try to begin our lecture and try to understand how R works with scalars and data vectors together. So now the question what we are trying to answer here is how R behaves with data vectors, and what happens when a scalar is added, subtracted, multiplied, divided, or there is a power operation, or a data vector is added, subtracted, multiplied, divided, or there is a power operation in a data vector. So these types of things we will try to understand with the help of some examples, which is easy for you to grasp. So let me try to take a different types of example and try to show you that how are we going to work. So in this case I am trying to take here a data vector of 4 values 2, 3, 4, 5, which is created by using the command C, right, and I try to add here the scalar 20. So now what you will see here, what is really happening, this 20 is being added to 2, 20 is being added to the next number 3, 20 is being added to next number 4, and 20 is being added to the next number 5. And you get here this outcome 22, 3 plus 20, 23, 4 plus 20, 24, and 5 plus 20, 25. So you can see here the way R is working is that the scalar is being operated on each and every member of the data vector. This is the basic fundamental. The same thing will continue when you try to operate with say subtraction, multiplication, and division also. So I have explained you here. Now it will be very easy for you to understand when I go for different operations, right. Now the next thing is this, when you are trying to add two data vectors. So what I try to do here, that I am trying to take here two data vectors. This is here C2357 and C67, right. So what you will see, what is happening, that first of all this pair is coming here, 6 is added to the first value, and then the 7 is added to the second value, and after that what's happening, 6 and 7 they are plus 7. Answer is coming out to be here like this 8, 10, 10, 12, and this is here a screenshot. Now at the same time, if I ask you what will really happen if I try to take here both the data vectors of the same size like C 2, 3, 4, 5, and say here C say 1, 3, 5, 6, and if I want to add it, then it is extremely simple that all the numbers at respective positions they are added. So the first element of first and second data vector, they will be added, answer will be 2 plus 1, 3. Then the second elements in both the data vectors, they will be added 3 plus 3, which is 6. Then the numbers at the third place 4 and 5, they will be added together, answer will be 9. And finally the numbers at the fourth place, they will be added together with the answer as 5 plus 6. So the moral of the story, what you have to learn is that here if I try to take the data vectors of the same size, then the values at the respective positions they are added together, and if I try to replace addition by subtraction, multiplication, division, then the same operation will happen, that the operation will be done on the basis of respective places, right. So, this is say straightforward and very easy to understand, right. Now, if I make two data vectors of different sizes, then you see what happened. I try to take here one data vector at 2, 3, 4, 5 and another here is 6, 7, 8. So, what happens that if I try to write down a 2, 3, 4, 5 and here C 6, 7 and here 8, then what happened? The rule is the same. If I want to add it, then the numbers at the respective position, they will be added. So, 2 plus 6 will happen equal to 8, then 3 plus 7 will happen, 3 plus 7 is equal to 10, then 4 plus 8 will happen, which is equal to 12. Now, there is no number here. So, after this 6, 7, 8 will be repeated again after this. So, 5 and 6 will be added here as 11. But now, there are no numbers here, which is this place is blank. So, now it will not operate, but it will give you a warning message. So, you can see here the outcome is coming out to be here like this 8, 10, 12, 11, but there is a warning message and it is saying that the longer object length is not a multiple of the shorter object length. For example, if you try to see the length of the first data vector here is 4 and the length of the second data vector here is 3. So, 3 is not really a multiple of 4, whereas in the earlier case the length of the first data vector was 4 and the length of the second data vector was 2 and 2 is a multiple of 4. So, this is what really is meant by the statement that longer object length is not a multiple of the shorter object length. So, you can see here that this is how the operation is going on and this is here the outcome, right. And the same thing happens with the subtraction also. So, if you try to take a data vector say C 22, 23, 24, 25 and you subtract it by 20, then the answer will be here like this. Each of this value in the respective in the data vector will be subtracted by 20. So, 22 minus 20, 23 minus 20, 24 minus 20, 25 minus 20, which is 2, 3, 4, y. This is the same operation which happened in the case of addition. And now, similarly, if you try to take here two data vectors where the length of the data vectors, they are exact multiple. So, you can see here I am taking here first data vector which has the length 4 and the second data vector C 10, 20 which has the length 2. So, what will happen here? This 10 and 20 will come here and they will try to operate over 22 and 23 and then after that once again this 10 and 20 will come and they will try to operate over 24 and 25, right. So, you can see here the operation will be like 22 minus 10, 23 minus 20, 24 minus 10 and 25 minus 20 and the answer will be here like this. So, that is straightforward. And at the same time, as I told you in the case of addition, if I try to take here two data vectors of the say here of the same length, suppose if I take here C 10, 12, 14 and 16 and I take another say this the data vector here say 2, 3, 4 and here 5 and if I want to subtract them, then the subtraction will be done at the respective positions. For example, 10 minus 2 will be here like as 8, 12 minus 3, 14 minus 4 and 16 minus 5, right. So, the rule is once again the same, that all the numbers at the respective position, they will be given the same operation which is being done. So, and then 25 minus here 10, right. So, this is how the things will happen in this case, and but it will give you here a warning message that not a multiple of the shorter object length, and this is here the same message. So, let me first try to do all this calculation on the R console so that you become more confident, and after that I will try to go for other operation. So, if you try to see here, if I try to take here the say two data vectors say C 1, 2, 3, 4 plus C say 3, 4, 5, 6, then you can see here the answer will be like this. All the values at the respective positions, they are added together. Then if I try to go here like this, C1, 2, 3, 4, they are added with, say here, say the data vector of, say here, to length, say 2 and 4. So you can see here that the first, this 2 and 4, first 2 and 4, they are added to 1 and 2, and then once again they are added to 3 and 4. On the other hand, if you try to take here only a scalar value, say here, say 4, then you can see here that 4 is added to each of the number. Yeah, on the other hand, if you try to take here the data vector of, say, different length, then you can see here that this 2, 4, 5 in the second data vector, they are added here to the first data vector and in the first 3 places, and then now that is repeated again. So 4 plus 2 will happen, but after that it is trying to say that be watchful, be careful, and the length of the data vectors are not the exact multiple. Right. And the same thing you can do with the subtraction also, say 10, C 10, 11, 11, 12, 13, if you try to see here, and if you try to subtract here minus 10. So you can see here 10 minus 10, 11 minus 10, 12 minus 10, 13 minus 10 has happened. Now if you try to take here the data vector of the same length, say 2, 3, 4, 5, all right. So you can see here there is a problem. You know what is the problem? The problem is that, as I told you, that this R is a case sensitive, so I have made here the capital C sign. So it has to be small c. So you can see here this will come out to be 8888. And if you try to reduce the length of the data vector, even then there is no problem. So it will give you the value 88, 10, 10. So you can see here it's not difficult to understand these things actually in the R console also. And so let us come back to our slides and try to understand other operations. Right. So now the same thing will happen to the multiplication also, that if I try to take a data vector C 2, 3, 4, 5 and I try to multiply it by 6, then so every element of the data vector is being multiplied by 6. So you will get here this outcome 12, 18, 24, 30, and yeah, so that is the same thing as you did in the case of multiplication, the case of addition and subtraction also. Now similarly, if you try to take here two data vectors of the same length, say 2, 3, 4, 5, C minus 2, minus 3, minus 4, 6, then what will happen? The numbers at the respective places, they will be multiplied together. For example, this 2 and minus 2 will be multiplied together. Then 3 and this minus 3, which are at the second positions, they will be multiplied together. Then the numbers at the third position, 4 and minus 4, they will be multiplied. And finally, the numbers at the fourth position, 5 and 6, they will be multiplied like here. Right. So this thing will happen here, and yeah, so that is pretty simple. And now even if you try to take the two data vectors of different length, but the length, they are the exact multiple. So if I try to take the first data vector having length of 4 and second data vector having the length of 2, so this is an exact multiple. So 6 and 7, first they will be multiplied over the first two element 2 and 3. Then once again they will come and they will try to multiply 4 and 5. So the outcome will be 2 into 6, 3 into 7, 4 into 6 and 5 into 7, like as here this 12, 21, 24, 35. That is the outcome. And similarly, if you try to take the data vectors of different lengths, the same thing will happen. Here you have a length of 4, here you have length of 3 in the second data vector. So this 6, 7, 8 will be multiplied to the first 3 values in the first data vectors, and then it will repeat it again. So 6 will be multiplied by 5 and the remaining 2 will not be multiplied, but it will give you here a warning message that the longer objective length is not a multiple of the shorter object length. So that is the same concept which I explained you in the case of addition and subtraction. Now for the division, the operator is the same like this one, backslash, and then now the same thing will happen. if you try to write down the data vector, see 10, 12, 14, 16 divided by 2, then each of this number 10, 12, 14, 16 will be divided by 2, like as here, and the answer will be 5, 6, 7, 8. And similarly, if you try to take here 2 data vectors, then the same division operator will be operated over the respective position. So, in the first data vector there are 4 elements, in the second data vector there are 2 elements. So, these 2 elements will be operated from here to here first, and then they will be repeated again over the next 2 numbers. So, the outcome will be like 10 divided by 2, 12 divided by 4, then 14 divided by 2 and 16 divided by 4, like this one. And similarly, if you try to take data vectors of different length, for example, the first data vector is of length 4 and the second data vector is of length 3. So, then what will happen? This the second data vector will operate over the first data vector at the first 3 places 10, 12, 14, and then it will come again. The 16 will be divided by 2, but it will give you here a warning message that okay, something is wrong, and you have to be careful that the longer objective length is not a multiple of the shorter objective length. And same thing happens with our operations, that if you try to take here a data vector, say C3, 4, 5, 6, and you make it at hat 2, then what will happen? Every element of this data vector will become a square, like 3 is power of 2, 4 is square, 5 is square, and 6 is square. And the answer will be here 9, 16, 25, 36. And similarly, if you try to take here say 2 data vectors, and the data vectors, they are of the exact multiple. So, first the data vector has 4 values, second data vector has 2 values. So, C3, 4, 5, 6 and hat C2, 3. So, this 2 and 3 will come here, 3 square, and here 4 cube, and once again 5 will become 5 square and 6 will become 6 cube. So, this will be here like this 9, 64, 25, 216 through this operation. And in case if you try to take here the data vectors of say this longer length, say 6 and 3. So, but here there is no issue because 3 is an exact multiple of 6. So, it will give you that 1 is square, 2 cube, 3 power of here 4, then again 4 is square, 5 cube, and 6 is power of here 4, like this thing, and the outcome will be here like this one, right. So, you can see here that is a straightforward calculation, and if you try to take the data vectors of different lengths. So, first data vector has 4 elements and second data vector has 3 elements. So, this will be like this, this will become 2 cube, 3 is power of 4 and 4 is power of here 5, and then once again 5 cube, but after that there is no number. So, it will give you here a warning message. So, you can see here that is pretty straightforward, and now let us try to see these operations over the R software actually. So, let me clear this screen, and if I try to take out here C 2, 3, 4, 5 multiplied by here 7. So, you can see here every element is being multiplied by 7. And if you try to multiply this by another data vector, say 5, 6, 7, 8. So, then the numbers at the respective places will be multiplies 2 into 5, 3 into 6, 4 into 7 and 5 into 8, right. And if you try to take the data length of the second data vector only as here 2, say, then you can see here that here the first 2 position in the data vector, for the first data vector 2, 3 will be multiplied by 5 and 6 respectively, and the third and fourth values will be multiplied by the 5 and 6 respectively. And if you try to make here the data length not to be multiple of the exact multiple of the longer data length, then it will become here like this. 2, 3 and 4 will be multiplied by 5, 6 and 7 respectively, then 5 will be multiplied by 5, and after that there will be a warning message. And yeah, the same thing you can do with the division also. I can show you here, say C, say here 2, 4, 6, 8 divided by here 2, you can see here. So, every element will be divided by 2, and if you try to take here both to be the data vectors here, say 3, 4, 5, 6. So, again every element will be divided by the respective element at its place. And then if you try to make the data length to be shorter but exact multiple of the longer length, then it will happen like this. 2 and 4 will be divided by 3 and 4 respectively, and then again 6 and 8 will be divided by 3 and 4 respectively. And if you try to make this data length to be say 3, the second data vector length is 3. So now which is not an exact multiple of the first data vector. So it will give you the values like the first 3 places are being divided by first 3 places of the second data vector, and after that 8 will be divided by 3, but then there are no more elements, so there will be a warning message. So you can see here that the operations are quite straightforward, and if you try to do the same operation with the power also, so C 2, 3, 4, 5, it will be here power here 2. So this will become 2 square, 3 square, 4 square, 5 square. And if you try to replace the second data vectors, second value as a data vector, so this will become 2 square, 3 cube, 4 square and 5 cube. And similarly, if you try to make here both the data vectors of the same length, so you can see here it will come out to be here like this: 2 square, 3 cube, 4 to the power of 5 and 5 to the power of here 6. And similarly, if you try to make this data length which is not an exact multiple, so it will give you the answer with a warning message exactly on the same line as we did it earlier. Right. So now we come to an end to this lecture, and once again I have the content of this lectures were very simple, but the more important part was that how R is working with the data vectors and scalar. That is more important for you to actually learn. And yes, these are very simple example I have taken, because my objective was to explain you that what is the functioning by which R actually works. But your job is to take some more complicated example and try to take something like more than one operation in a single command, like as BODMAS. And you can use even the brackets. So you try to do those simple calculation manually and try to do them on the R software and try to see that how you can do it. So this will require some practice, because it is very important for you to understand that how R works, what R understands. And we have to translate our requirement in the format of R software. So you please try to do those simple exercises yourself, and I will see you in the next lecture with more commands about the calculation with R. Till then, goodbye.